Right, so in this video I'm going to introduce complex numbers, and I'm just going to have a look at the basics. So let's start with what a complex number is, or where it comes from. So if you take an equation like this, say x squared plus, we'll actually say for this, just to start out, let's say minus 9 is equal to 0. If you were to solve that, then you would just simply take the 9, bring it over here, or add 9 to both sides, and you would end up with x squared is equal to 9, and that gives you x then is equal to plus or minus the square root of 9, which is just plus or minus 3. So plus 3 times plus 3 will give you 9, or minus 3 times minus 3 will give you 9. So that's fine. But what happens if you have x squared plus 9 equal to 0? Well, in this case, if you do the same thing, you end up with x squared is equal to minus 9, and then you end up with x equal to plus or minus the square root of minus 9. Now, there's no number that you can multiply by itself to give you minus 9. You can't get the square root of minus 9. I mean, 3 times 3 will give you plus 9, minus 3 times minus 3 will give you plus 9, but no number will multiply by itself to give you minus 9, so we can't actually do this. So what they've actually done here is, let's say we take x squared plus 1 equal to 0. Again, if you bring the 1 over, you get x squared is equal to minus 1, which gives us x is equal to the square root of minus 1, plus or minus if you like. But we can't again get the square root of minus 1. So what we've done when we talk about complex numbers, what they've done is introduced a letter called I, and that letter I is just equal to the square root of minus 1. So this is the basics of complex numbers. This is what you've got to remember all the time, that I is just the square root of minus 1. And you can use this fact to solve numerous equations, in fact, that involve the square root of minus 1 in their solutions. So let's have a look at how we can do that. So let's take, for example, let's say x squared minus 2x plus 5 equal to 0. So we have to solve this particular equation here, this particular quadratic equation. So we have to find where this cuts the x-axis, or find its roots. So normally you do that by drawing two brackets here and factorizing it, in other words, and working out what x is. That won't work just on first viewing, so really the way you're going to have to do this is use our formula. And the formula is x is going to be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So what we need here then is a, which is just what's in front of the x squared, which is 1. We need b then, what's in front of the x, which is minus 2. And we need c, which is our 5 plus 5. So let's just stick that into our formula, see what happens. Well, our x then here is just going to be equal to minus b. Well, b is minus 2, so b is going to be 2 here, or this part here is going to be 2, plus or minus the square root of b squared, so that's going to be minus 2 squared, minus 4 times a, which is 1, and c, which is 5. All of that is going to be over twice a, which is 1. So this is what we've got to work out here. So let's see if we can work this out. So we got 2 plus or minus the square root of minus 2 squared is just going to give us 4. Minus 4 times plus 1 is minus 4. Minus 4 times plus 5 is going to give us minus 20. And all of that is going to be over 2. 2 times 1 is 2. So what we end up with is 2 plus or minus the square root of minus 16 all over 2. Now the problem with this is we end up with a square root of a negative number here. Now we can't actually do that up to now, but we now know, as we've seen up here, that I is the square root of minus 1. So if we take that square root of minus 16 So I just work over here. So let's say that's going to be equal to 2 plus or minus. That minus 16 is just going to be minus 1 multiplied by 16. Minus 1 times 16 will give me the minus 16 here. So that's over 2. Let's see, then that becomes 2 plus or minus. I can split these up here, the square root up here. That's square root of minus 1 multiplied by the square root of 16. That's over 2 again, so I'll end up with 2 plus or minus. Now remember, the square root of minus 1 here is I, and the square root of 16 is 4, so I end up with 4i here. Remember, I is the square root of 1 minus 1. I is the square root of minus 1, so this is just I. Square root of 16 is 4. And underneath then I end up with 2, so just moving that on again over here, I end up with, I can divide this, well, I'll split it up first. So it's 2 plus 4i over 2, or it's going to be 2 minus 4i over 2. So if I work those out, then I'll end up with, let's see, I can take the 2 over 2 plus 4 over 2i, or 2 over 2 minus 4 over 2i, and that'll just give me that'll give me 1 plus 2i, or 1 minus 2i. So these are my two solutions here. Now these involve this I here, this imaginary, if you like. This I stands for imaginary, if you like. So it's it involves an imaginary number here, this 2i. This part here is real. So there are no real solutions to this. They're just complex solutions, or imaginary solutions, if you like. So what does that mean in practice in terms of the graph of that particular complex number? Remember, that particular quadratic. It was x squared minus 2x plus 5 is equal to 0. If we were to draw that, we're going to end up with something like that, where the graph doesn't actually cross the x-axis. Remember, if it crosses the x-axis, we'll get two real solutions. We don't have two real solutions here, we have complex solutions. Okay, so that's how it's used to solve these type of quadratic trinomial equations here. So let's just have a look at one or two other things then. So basically what we've done there is, you take, say for example, the square root of minus 9. You can rewrite that as the square root of minus 1 times 9. So that's just the square root of minus 1 multiplied by the square root of 9, which is really just, this is 3, and this square root of minus 1 is I. So that's what we did up here when we tried to solve this particular quadratic here. So you can actually rewrite the square root of minus 9 as just 3i. Now just squaring out these, let's have a look at squaring I and cubing I and so on. So let's take, we'll take I first of all, and we'll square it. Well, that's just going to be the square root of minus 1 all squared, so that's just going to give us minus 1. Let's take I cubed. Well, that's just going to be the square root of minus 1 cubed. So that's going to be square root of minus 1 times the square root of minus 1 times the square root of minus 1. So these two here will give us minus 1. When you multiply square root of minus 1 times square root of minus 1. So here we'll just get minus 1. This is I. So we just end up with minus 1i, or just minus I. Let's try another one. Let's say I to the power of 4. Well, that's just the square root of minus 1 times the square root of minus 1 times the square root of minus 1 times the square root of minus 1. Well, these two here will give me minus 1. These two here will give me minus 1. Minus 1 times minus 1 is just 1. So I to the power of 4 will give me 1. We'll do a couple more and then just move on. So let's say we'll take I to the power of 5. That's going to be square root of minus 1 times 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 square root of minus 1. So again, these two here will give me minus 1. These two here will give me minus 1, same as up here. And I end up with square root of minus 1 here, this here will just be I. So what do I end up with? Minus 1 times minus 1, which is plus 1, times I, which is just I. We'll do one last one. I to the power of 6. So again, that's just going to be, a pair here, which is just going to be minus 1. Another pair here of square root minus 1s, that's just going to give me another minus 1. And I'm going to end up with another 2 as well, so that's just going to give me another minus 1. So if I multiply these three together, this will give me plus 1 times minus 1 is just minus 1 here. Okay, so that's just squaring some i's and raising to the power of 3, 4, 5, and 6. So what about higher powers then? Let's have a look at, say, I to the power of 49. How would we do that without multiplying everything out? So let's see, this is I to the power of 49 is just I to the power of, let's do that again, that's just going to be I to the power of 48 times I to the power of 1. We add the indices here and we get I to the power of 49. So this I to the power of 48 here is just again it's just an I squared. It's I squared all to the power of 24, and again we have our I here as well. So 2 times 24 will give me 48 here. So we know here that I squared is minus 1, so that's just simply minus 1 to the power of 24. We got our I here on the outside as well, which we're multiplying it by. Now minus 1 to the power of an even number is just going to be plus 1. So I minus 1 to the power of 24 is going to be plus 1. So plus 1 times I is just simply I. So I to the power of 49 is just I. And that's how you do it. Normally what you do is, if it's an odd power here, split it up into an even power times I to the power of 1. And then when you have the even power, put I squared in the bracket, because you know what I squared is. I squared is just minus 1. And then you're going to have to divide this power by 2. So in this case we'll have 24 on the outside. I squared is minus 1. Raise minus 1 to the power of a number that's even, and that'll give you plus 1, and plus 1 times I will just give you I. Okay, so that's really it, I think, for the moment. In the next video I'll have a look at more complex numbers and Argand diagrams, multiplying them out, how you multiply out complex numbers and so on. So we'll have a look at that in the next video.